When we turn a switch on, it allows electrical energy to flow through the system. So if we have a dimmer switch like this one that's attached to a light bulb, when you turn on the switch, it allows energy to flow from somewhere through the light bulb. And so then the light bulb can generate heat and light. And it doesn't necessarily have to be a light bulb. It could be it could be a fan, it could be anything that's attached to the outlet where the switch is. Well, this is a dimmer switch. So what's happening when you move the dimmer switch up and down, when you make it brighter or dimmer? Does it have something to do with the flow of electrical energy? Well, it must have something to do with the flow of electrical energy. But what's happening? Is it moving faster? Is the energy moving faster? Is there more energy moving through the wire, but at the same speed? Is there some bigger amount? We have to think about this. We know that energy is measured in finite amounts. It's measured in joules. How do those joules flow through? How does that energy flow through the wire? Relate this to the types of energy that we already know about. If we turn on a switch and it turns a fan, well, we're converting some kind of energy to kinetic energy. What kind of energy have we learned about where you can convert it easily to kinetic energy? Well, we've talked about gravitational potential energy, where the position of a mass in a gravitational field will determine the amount of energy it has and how much energy can be converted to kinetic energy. We've talked about elastic potential energy, where if you stretch out a spring or a rubber band, the shape, the position of those molecules relative to each other, and their their tendency to want to return to their original shape will will make elastic potential energy. Well, here we have another kind of potential energy. This is electrical potential energy. Electrical potential energy, or electrical energy, can be stored. The electrical energy is the potential energy of charged bodies in an electric field. And charged bodies can be things as small as electrons, or things that contain a lot of electrons, or have a deficiency of electrons. So it can be small particles like electrons, or chemicals that are charged. They can be molecular ions that have excess electrons or missing electrons, and uh, they cause electricity to be able to flow. We already know that opposite charges attract. So if you have a positive end and a positive object on one side and a negative object on the other side, then the electrons will tend to flow away from the negative object and toward the positive object. When charged bodies move like this under the influence of electric force, and we know about electric force is just that attraction and repulsion between positively and negatively charged objects, or well, repulsion between similarly charged objects, and attraction between uh, oppositely charged objects. So that since this is something that initiates movement, that means that there's electrical energy there, electrical potential energy, and when that movement is it happens, then the electrical potential energy is converted to some other kind of energy. It might be kinetic energy. There might be a flow of thermal energy, internal energy, which would result in heat. There might be light emitted. Okay, there are electrical energy can be converted into different forms of energy. So, how do we store energy? Well, a common way is in batteries, and batteries can store that electrical energy, and they store it in chemical form. So they have a chemical potential energy that can When you attach the positive end of a battery to the negative end of a battery, then you can have electricity flow through the conductor, and well, from one end of that battery to the other and through the conductor. Electrical energy is stored in batteries, and then it's transformed into radiant energy in light bulbs. So that's a combination of heat and light.